In this nugget, you and I get to take a look at IPv4's ICMP through the eyes of Wireshark. Let's begin. If you, like me, enjoy the story of a hero, ICMP, the Internet Control Message Protocol, is definitely one of the heroes of the protocol stack. And if we look at this ICMP protocol, it does have a protocol number. In fact, it's protocol number 1. I can imagine ICMP and all of its friends marching down the road saying, "We're number 1! We're number 1!" So other protocols like TCP is protocol 6, and UDP is protocol 17 in decimal. So I suppose ICMP does get some pretty good recognition of the fact that it's protocol number 1, which we'll see inside of the Wireshark packet capture. And ICMP does a whole bunch of stuff for us, including, for example, if we have an administrator sitting at R1 and we do a ping request, and we do a ping out to 10.0.0.2, the underlying protocol that's being used is ICMP, with a specific message of an echo request, and if R2 is able to respond to that, R2 will respond with an echo reply. Now you might ask, well, what would cause R2 not to be able to respond to that? Well, if R2, for whatever reason, didn't know how to get back to the IP address of R1, that would prevent it from doing a reply. Or if there was an access control list on this interface that was preventing the traffic from being processed by R2, instead of doing an echo reply, R2 could send an unreachable message back saying, "Oops, sorry, I killed your packet. Here's the details regarding what you were trying to do. However, because I have an access control list that's denying that traffic on that interface, I'm not letting that packet be processed, but I am sending you an ICMP message back with the details of why I killed your packet." Redirects can be used when a router knows that there's a better path to reach a given destination. So that's going to be helpful in letting other devices know about potentially better paths through the network. Or if we have some device that's overwhelming the recipient, we can do source quench. That functionality through ICMP can let the sender know, "Hey buddy, you need to slow way, way down. I can't handle all this data that's coming in at me." Or if a router sees a packet that has the TTL, the time to live, and that TTL has expired, it's an ICMP message that's going to be sent back to the source saying, "Hey, I killed your packet because the TTL expired." So what you and I are going to do, we're going to use this topology with R1 and R2. We'll create a sample access control list. We'll put it right here on interface 1/0. And then we'll throw some traffic between R1 and R2 and take a look at the traffic as we capture it right here on this link between R1 and R2. So we're going to start on R2. Let's create a sample access control list. We'll call it sample-ACL, and it'll have one entry in it that says deny IP from anywhere going to anywhere. This is a very, very restrictive access control list. To put this access control list to work, let's apply it inbound on interface 1/0 here on R2 by going into interface configuration mode and using the syntax IP access-group, the name of the access control list, and the keyword in to represent inbound. We can verify what access control lists exist on this router by using the command show access-lists. So we have our single access control list, that's great. And we can also verify it's applied to an interface by doing a show IP interface for E1/0. And I'm going to use the pipe symbol and say include list. That way the output will only show output where the word list is in the output. So this just confirms that our access control list called sample-ACL is indeed applied inbound on interface 1/0 of the router R2. So with that in place, let's begin our capture. We'll go back to GNS3. We'll right-click on the link between R1 and R2 and click on Start Capture. And then we'll click on OK. We'll minimize Wireshark for a moment. We'll come right back to that. Let's go back to the console and let's make a road trip over to R1. And on R1, let's try telnetting over to 10.0.0.2. Now, right away, it gave us a message saying destination unreachable, gateway or host down. And that's because we got an ICMP message back from the router telling us that it killed that traffic. So let's try a ping to 10.0.0.2. And that also should fail. And this time we have UUUU showing up in the response on the router, which indicate that it's unreachable. And it knows it's unreachable because that's the type of ICMP message it got back from R2 when R2 was denying each one of those ping requests that were coming in. So let's bring up our Wireshark. I'll go ahead and click on Stop to stop the capture. I'm also going to stop it inside of GNS3 as well. By going to GNS3, right-clicking on the link between R1 and R2, and from the drop-down saying Stop Capture. So back in Wireshark, we'll go to the very first packet in this capture. And packet number 5 is the initial SYN request that R1 was making as part of his telnet session. And then immediately following that, we have this ICMP unreachable message that's being sent from R2 back to R1 apologizing for the fact that it just killed that packet. And the purpose of this ICMP unreachable is to let the sender, in this case R1, know that the packet was denied. So here in packet number 6, if we look at the details of that, at layer 3, we have the source of 10.0.0.2, which is R2, and the destination of 10.0.0.1, which is R1. If we look at the next protocol on the stack, it's pointing to protocol number 1, which is ICMP. And unlike transport protocols like TCP and UDP, ICMP is a special case. It does have its own dedicated protocol number, and it's not used for our typical applications like SSH or Telnet or HTTP or HTTPS or DNS. Those protocols would typically use TCP or UDP respectively, while ICMP is a special case protocol that the IPv4 protocol stack can use as its right-hand man to communicate messages back and forth between devices regarding real-time situations that are happening on the IPv4 network. So if we collapse the layer 3 information and look at the ICMP protocol information, I'd like to ask you a question. What should we expect to see in this ICMP message, which is from R2 going back over to R1? I would expect two basic things. Number one, it should say I killed your packet, and secondly, it should give us details about the packet that it killed. So we expand that and take a look. There's our type 3, which is a destination unreachable, and a code 13. Check this out. Calling all cars, this is a code 13. It says communication administratively filtered. So it's giving us a detailed reason why the destination that R1 was trying to get to, why that was unreachable. And it's because that access control list was filtering it inbound on the interface E1/0 of R2. And as the plot thickens, it also gives us details regarding the original traffic that was being denied, what it was all about. So as we expand this piece right here, it's telling us about the initial traffic. This is ICMP from R2 to R1 saying the initial traffic that was just killed was using TCP. It was from 10.0.0.1 to 10.0.0.2. And furthermore, regarding that packet that was denied, the layer 4 information indicates that it was trying to go to the well-known port of 23 for Telnet because we were trying to initiate a Telnet session, and it was being sourced from the port 65,404, which would have been the random port that R1 simply chose out of the air and was going to use for the Telnet session that it was trying to establish. If we scroll down a little bit further, here we have our ping request that we attempted to send over to R2. And that's in packet number 11. And in packet number 12, we have our ICMP message coming back. And the ICMP message that comes back says destination unreachable. It was administratively filtered. And then just as before, it'll give us additional details regarding the original packet that was being denied. And so for our ping request, we were trying to send an echo request from 10.0.0.1 to 10.0.0.2. And it was denied because of the access control list inbound on Ethernet 1/0. So I'm going to save this capture. We'll call it IPv4 ICMP, and now that's available to you as part of the Nugget Lab files. In this nugget, we've taken a look at ICMP for IP version 4 through the eyes of Wireshark. I have had a great time in this nugget. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.